topic is continuity of a function. So whether a function is continuous or discontinuous, what are the factors? Now, to be continuous, a function to be continuous, it should have three requirements. It means three requirements. Number one, the points must be in the domain of the function. So we must always remember domain and range. So we discussed earlier that domain, all the input or the variable factors in the right side and the range in the left side. Here range is L, Q, and variables are V, domains, and this is range. So all the requirements meet at point N. Point N is domain, as I said. So out of total V, total inputs V, or there are different levels of V, so they are represented by N. Okay? And Q has the limit L as V tends to N. So 0, so N1, N2, N3, so on up to V, or V1, V2, V3, so on up to V, total V. So V tends to be N. So if we put N for V, so these different levels of V represented by N1, N2, and so on, and corresponding Q, it is actually Q1, Q2, but range is represented by L1, L2. So Q has the limit L as V tends to N. Now L is also the value of the function at N. So at every level of N, L is the value of the function. As I say, it is a range value of the function. The function is continue at N. So it is said that the function is continue at different levels of N. Then number two, the function must have a limit as V tends to N. In figure B, so this is figure, now coming to figure B, the function is continuous. L is the limit as V tends to N. So when V tends to N, so L is the limit. 0 to L. That is the limit in domain. L is also the value of the function at N, as you said earlier also. So this is when L is this much. That means this much of V. N means this much of V. As we said earlier, if we put this much of V or this much level, then output, that means range may go up to L. So L is the limit. Then number three, the limit must be equal in value to Gn. So in figure C, in the third picture, in figure C, the function is discontinuous. You see, earlier it was continuous, and this time it is discontinuous. Okay. The function is discontinuous at N as limit does not exist. So in C, limit doesn't exist at that point. Second requirement of continuity is violated. So when limit doesn't exist as entity, the requirement 2 is violated. at interval 0 n, so 0 to n of b, 0 to n, and at n to infinity. So when n is very, very large of the domain, it fulfills the requirement of continuity. So at very, very large n, almost infinity, then it fulfills the requirement of continuity. But at lower level, it does not fulfill the requirement of continuity. That means requirement 2 is violated. In figure D, again the function is discontinuous at b is equal to n. So when b is n, it is said it is discontinuous. It is declining. As n is excluded from domain, so it is n, some level of b is excluded from domain. It violates one requirement of continuity. So first requirement, the point must be in the domain of the function, so it violates. You see? So earlier it was here, then with the increase in the level of n, that means level of b, so it declines. It declines. So if it further declines, it will exclude. N will be excluded from domain. It violates n requirement of continuity. The sharp points are consistent. It is said that the sharp points are consistent, as in B. Sharp points are consistent. There should not be gap, as in C and D. So in C and D, there is big gap. Now here it is continuous. So this is all about the continuity of a function in short. Okay, thank you. Keep on watching.